In the last section of Module 2, we are going to talk about equations of parallel and perpendicular lines. Before we do that, we have to talk about how to write an equation of line. The most common form is the form slope-intercept. So that's y equals mx plus b, where m stands for the slope of the line and b is the y-intercept. Hence the name slope-intercept. So looking at our first example, we want to write an equation in slope-intercept form of the line with a slope of -4 and a y-intercept of 1. So given we have y equals mx plus b, and we know m equals -4 and b equals 1, we end up with the equation y equals -4x plus 1. In our second example, we want to write an equation in slope-intercept form with of the line with the slope of 5 and a point at 0, -8. So we know that m equals 5, and we know a point. Well, the nice thing is anytime you have a point where the x-intercept, where the x value is 0, the y value is always your y-intercept. So that tells us that b is -8. So the equation of our line is going to be y equals 5x. And then instead of plus -8, I'm just going to write it as -8. And in our third example, we want to write an equation in slope-intercept form of the line with a slope of -2 and a point at -3, 6. So unlike our previous example where the point was the y-intercept, we aren't given that in this example. We know that m is -2. So as of right now, we know we have the equation y equals -2x plus b. And we need to find some way to find the y-intercept. Well, the nice thing is, since we're given the point -3, 6, there's only one possible y-intercept with our slope that passes through that point. So I'm going to plug in the value -3 for x and the value of 6 for y and then solve for b. So we'll get 6 equals -2 times -3 plus b. So we get 6 equals, and then -2 times -3 is 6 plus b. Subtract 6 from both sides and we get that b equals 0. So our y-intercept is 0. So we end up with the equation y equals -2x. We could put plus 0, but since that doesn't actually, plus 0 doesn't actually do anything, we can leave it as y equals -2x, and that is the equation of the line. So in our fourth example, we want to write an equation in point-slope form of the line whose slope is -3/5 that contains the point -10,8. Now we didn't talk about point-slope form. It's not really all that difficult of an equation. So it's y minus y1 equals m and then in parentheses x minus x1. So m is still the slope, and then x1, y1 is the point you're given. So with our equation, we're going to have y minus our y value, which is 8, equals our slope, which is -3/5, and then in parentheses x, and then it would be minus -10, which is going to, so x minus -10. Now, because it is x minus a negative number, we're going to go ahead and change that to addition. So we get y minus 8 equals -3/5, then in parentheses x plus 10. So this is another way to write an equation. We're given the slope and a point on that line that is not the y-intercept. You could use, like the previous example, example 3, we could solve for the y-intercept, but because the slope is a fraction, that can get kind of difficult. It may end up with the y-intercept is a fraction as well, so this is a nice alternative that we don't have to worry about fractions. So let's write an equation in slope-intercept form for a line containing the points 4, 9, and -2, 0. So the nice thing is that there's only ever one line that passes through 2 points, so we don't have to worry about there being multiple possibilities for an answer here. So let's go ahead and find the slope first. So remember, the slope is found by doing y2 minus y1 over x2 minus x1. So using the point -2, 0 as our second point, we'll do 0 minus 9 divided by -2 minus 4, which is going to give us -9 over -6. So the negatives are going to end up canceling, and then we also want to look to see if our fraction simplifies well. 9 and 6 are both divisible by 3, so we're going to end up with a slope of 3/2, since 9 divided by 3 is 3, and 6 divided by 3 is 2. Now all that's left is to find our y-intercept, and neither of the points we're given is the y-intercept, so we're going to have to solve for it. So we have the equation y equals 3/2 x plus b. Now I get to choose which point I'm going to plug in for x and y to solve for b. And since my slope is a fraction, when I multiply it by an x value, I'd like to multiply it by a number that's divisible by my denominator, which is 2. And luckily, both of our points have an x value that is divisible by 2. So it doesn't matter which point we choose. So I'm going to go ahead and choose the one that contains, I'm going to choose -2, 0. So I'm going to place 0 equals 3/2 times -2 plus b. So we're going to get 0 equals, and the reason why I wanted a x value that's divisible by our denominator is I want to divide that first. So -2 divided by 2 is -1, and then times 3 is going to give us -3. The other reason is we got rid of all of our fractions since we could cancel it with our denominator. And then to solve for b, we're going to add 3 to both sides, so we get that b equals 3. I now know the slope and the y-intercept of my line, which means I can write the equation. So the equation of our line is going to be y equals 3/2 x plus 3. Next, we want to write an equation in slope-intercept form for a line containing the point 1, 7 that is perpendicular to the line y equals -1/2 x plus 1. So the only thing we care about from the equation of this line is the slope, which is the -1/2. So if you remember to our previous example, perpendicular lines, their slopes multiply to give us -1, or I said you think of it as their slopes are opposite reciprocals. So I know the slope of my perpendicular line is going to have an opposite sign, so it's going to be positive, and I want to do the flip, which is the reciprocal of 1/2, which is going to be 2 over 1, which is just 2. So the slope of my new line is 2, and I know it passes through the point 1, 7, so now it just becomes kind of similar to our previous example where we have to solve for the y-intercept. So we're going to have y equals 2x plus b, plug in our point for x and y, and we're going to get 7 equals 2 times 1 plus b. So we get 7 equals 2 plus b, subtract 2 from both sides, and we get that b equals 5. So our line that is perpendicular and passes through the point 1, 7 is going to be y equals 2x plus 5. And if you were to graph both of these lines, you would see that they are perpendicular. So our last example is going to be write an equation parallel to the line 4x minus 2y equals 10 and passes through the point 1, 1. So remember, parallel lines have the same slope. But our equation 4x minus 2y equals 10 isn't in our slope-intercept form. So we don't really know what the slope is yet. So the first thing I'm going to do is get that equation in slope-intercept form. So we have 4x minus 2y equals 10. So I want it to be y equals. So my first thing I'm going to do is subtract the 4x. So we get -2y equals -4x plus 10. Lastly, I need to get rid of this -2, which means I'm going to divide everything by -2. So with the equation, y equals -4 divided by -2 is 2, so 2x, and then 10 divided by -2 is -5, so it becomes -5. So y equals 2x minus 5 is the same equation and the same line as 4x minus 2y equals 10. Now that it's in this form, I can identify the slope for my parallel line. So parallel lines have the same slope, which means it's still going to have a slope of 2. Now I'm going to use my point to finish writing the equation of my line. Again, 1, 1 is not the y-intercept, so we have to solve for it. So we're going to have y equals 2x plus b. Plugging in 1 for x and y, we get 1 equals 2 times 1 plus b, which becomes 1 equals 2 plus b. Subtract 2, and we get that b equals -1. Now I can write the equation y equals 2x minus 1. So this is the equation of the line that's parallel and passes to the point 1, 1.